Students, I hope that you've had fun and learned something while creating your own triangle and quadrilateral using the applet, recording all your measurements here. Now you're ready for slides E and F. In these slides, you'll make a quadrilateral using the same side lengths as a student named Diego. And you'll measure the angles and put your results here. Next, you'll also make a triangle that has the same side lengths as a student named Jada. Build the shape and record the angle measurements here for the shape that you've created. It will be very interesting to see if you make the same shape that Diego and Jada make. However, there's a little controversy that arises when you compare shapes that you make here in the applet compared to shapes that these other students have made. It turns out that it's very difficult to make two shapes that are exactly the same using this applet, even if we try, which creates a little math controversy. To help you resolve this controversy, I've created a slide before slides E and F, which I've shared with your teacher. The next part of the video will explain the controversy, the problem, and also guide you as you and your classmates use this slide to resolve the problem. The protractor that measures the angles is so exact it actually goes to the hundredths place. So as I make a triangle and I measure the angles, I'm measuring a 3, 4, 5 triangle, which you'll find out in the future is kind of a classic triangle in mathematics because it has certain qualities that make it special. Click the protractor, measure the angle. See, this is 91.39. I will now try to make a triangle exactly the same by putting all the points, all the vertices of the second triangle exactly on top of the vertices for the first triangle. And then I'm doing a little experiment to see if I can get the exact same angle. I will try, but we may not. Let's find out if I can get the exact same angle. Protractor. Select. And as you can see, it really is the same triangle, just about the same triangle. It's so close. And the angle measurements are so close, they're only off in the hundredths place by 7/100ths of a degree. So it's really difficult to make triangles that even if we want to make the exact same triangle, it's hard to get it exactly the same. Just to make it a bit more clear, I've moved the second triangle away from the first one. And now we've labeled these triangles, triangle 1 and triangle 2. The measurements of the angles are pretty close, but not exact. If we round them off to the nearest whole degree measure, 91 for this angle here, and for angle A on triangle 2, these angles here round off to 36 degrees, but they're not exactly the same. And these angles, this would round up to 52 degrees. It's already a whole number. And this would round off to 53 degrees. Since we will need to compare shapes to decide if they're equal or not, I will present a strategy for helping us prepare for slides E, F, and G. Then we'll go back to the slide before slide E to resolve this controversy. One strategy we can use to resolve the problem and to compare any two shapes like we're going to need to do in slides E, F, and G. What we can do is this. Take a photo of each shape and then superimpose, which means place one on top of the other. See if they match up perfectly. For example, what do you think of these two triangles? Are they the same, congruent, which means equal in geometry, or are they different? Pause the recording here, then press play to continue. Well, one thing you might need to do, first of all, let's see if we can superimpose. At first, it seems like we can't. But then again, what if we rotate the triangle? Which you can do in slides. Now let's see if we can superimpose, means place one right on top of the other, and if they're exactly the same. I'm going to click it and drag it over, but in such a way that you can still see both copies. Once I let go, then one copy will block the other one. But see what I'm doing here? What do you think? Are they the same triangle? Are they congruent? Pause the recording here, then press play to continue. I agree, yes, they are congruent. So even though they started looking different because they're oriented different, once we rotate the shape so they're in the same position, we can superimpose and then see if these triangles are congruent or not. And in slides, you can see both at the same time, even without holding the clicker on the mouse. Now that you have this strategy, let's use this slide, which I've added to the document and share with your teacher, to resolve the problem. To answer this controversy, you will find this slide right after slide D. The teacher in the video, that's yours truly, Mr. Blinn, tried to make the same triangle in the applet. This is the best he could do. Plan. Move one triangle on top of the other to answer the question. Are they the same, congruent, different, or close enough to say congruent for our investigation? So take the one triangle, superimpose it, and what do you think? Pause the recording here so you can write down your thoughts here. Share them with your classmates and your teacher. Then press play to continue. When you're ready, please go to video 3.